Hello and welcome to helpyourmath.com. In this video, we're going to take a look at solving literal equations. What is a literal equation exactly? A literal equation is an equation with multiple variables. So maybe it has an x and a y, or an a and a b, or a c and a w. It could be widely recognized, or it could be something that I just made up. The directions will indicate which variable you need to solve for, and your goal will be to isolate the variable. We solve literal equations the same way we would solve any linear equation in one variable. We want to get the variable by itself, the designated variable, and we do inverse operations to move everything to the other side. The trick to literal equations is that we might not be able to combine everything because they might not be like terms. Let's start by looking at some formulas you might see in math or somewhere else. First up is a geometric formula. It's the circumference of a circle, which is given by circumference equals 2 times pi times r, where r is the radius. In this formula, currently, it is solved for c, the circumference. But now, the directions indicate that we want to solve for r. So our goal is to get r by itself. What's happening to r? Well, it's being multiplied. How do we undo multiplication? We would divide. So what we're going to do is we're going to divide both sides by what's being multiplied to r. Now, can I actually divide c by 2 times pi? Well, no, because c is a variable. So we're just going to write it, and I'll use the commutative property to flip this around. I'm going to say r equals c divided by 2 times pi. Now we have this formula solved for r. In the next example, you might see this in business. This is a profit function. So the profit is the revenue minus the cost. We want to solve for r of x. So this is function notation, this like p parenthesis x, r parenthesis x, c parenthesis x. And each of those are just read that variable in front of x. So we want to solve for r of x. I'm going to highlight it so we can clearly see. And now, what's happening to that highlighted r of x? Well, it's being subtracted by my cost function. So let's add c of x to both sides. And this can be a little weird because it almost kind of looks like we could combine these. I mean, they both are functions of an independent variable x, but we don't combine them. So we would write this p of x plus c of x is equal to r of x. And if we want to flip it around using the commutative property, we could. We could put the r of x in front, but as of now, we have r of x by itself, so this is sufficient. So this would be another way to interpret this formula in terms of revenue. Okay, we're going back to geometry. We have perimeter of a rectangle. Perimeter of a rectangle is given by the formula perimeter equals twice the length plus twice the width. In this instance, it's asking us to solve for w. I see we have this 2L being added to 2W. There's also a 2 being multiplied to w, but just like we would if this was a regular normal looking equation, we want to undo addition and subtraction first. Since we have a positive 2L being added, I'm going to subtract 2L from both sides. And then this gives us p minus 2 times L equals 2 times W. So now I have the term with W by itself, but I still have a coefficient that's not 1. I have this 2. To undo a times 2, I need to divide by 2. We can divide the left-hand side in one of two ways. Either we just divide the entire left-hand side and we leave it like this. This is totally fine. So we would say p minus 2L divided by 2 equals W. Or alternatively, I'm just going to rewrite it, p minus 2L equals 2W. You can divide each term by 2. If we divide each term, then it's going to look like this. P over 2 minus 2 divided by 2 is 1. We just have L equals W. Either of these is totally fine. In terms of when we get to linear equations in two variables, you probably want to do the separate division, so the second way I showed. But when we're just solving for a variable, and then, that's kind of like the whole point of the problem, you can really do it either way. And then since this way is less work, I would always advise this way. But either of these two are perfectly correct. We've solved for W, and we've done appropriate math to get there. This last one you might have seen with coordinate geometry, the slope formula. So the slope formula, where m is the slope, is the change in the y-coordinates over the change in the x-coordinates. And it looks like we're going to solve this one for y sub 2. So that's This guy here is the one we want to isolate. So how will we do this? I see the subtraction of that y sub 1. However, because it's all over a giant fraction, we probably need to take care of that giant fraction first. I do have some students who are fraction phobic. I advise to just rewrite every term to have the same denominator. In a case like this, where there's only one term on the left-hand side and one term on the right-hand side, I would instead suggest putting m over 1, which is actually what I would do for the fraction anyway, but turn this into a proportion, because there's a mathematical principle that says cross products of proportions are equal to each other. So we would have m times x sub 2 minus x sub 1, x2 minus x1, equals 1 times y2 minus y1. And depending on what the overall goal is for this, you can simplify as much or as little as you'd like, or you would ask your instructor what they would prefer. Because now to get y2 by itself, I'm over here on the right side, I need to add y sub 1 to both sides. Y sub 1 has no like terms, right? There's no other y's, let alone y sub 1's. And so we could just say this is going to be m times x sub 2 minus x sub 1 plus y sub 1. Commutative property says I can move this around and put the y sub 2 over here. Or if your instructor insists you remove the parentheses, you would distribute the m and have the 3 separate terms. I would think this is sufficient. I always am a believer that when you can do less work, do the less work. So far, so good? Why don't we pause the video and see how you do with these two? I know, I pulled a fast one on you because both of these have fractions. I'm so sorry. What we could do for the first one is we could, again, kind of treat this like cross products. What we can do, since this is all one term, right, everything's being multiplied, is technically these go over 1, so you could put mv squared as the numerator over that denominator of 2. And then this equals, and again, we could do the cross products if you wanted. We could put k over 1. What is my even goal here? Oh, it's to solve for m. Okay. I saw the fraction, thought you might have panicked, so then I sort of panicked too. But we could do this, and then we could do the cross product. So k times 2, we would say, is 2k. And 1 times mv squared would just be mv squared. And now to get m by itself, it's being multiplied by v squared, so I would divide both sides by v squared. I don't have any same bases. I can't simplify this at all. I could use the commutative property to flip that m around and say m equals 2k over v squared. I have solved for m. So this little fun formula comes from physics, the kinetic energy formula. And last up, this is the one that I have to use in foreign countries because as an American, I don't know Celsius, I don't understand it, and I only understand Fahrenheit. So this is the temperature formula. It's currently solved for C, but I need it solved for F because I only understand things in Fahrenheit. First, I notice I have this 5/9. And we can almost do the same thing that we did for the previous two problems. I could put this whole thing over 1. These are being multiplied, and I could write this as 5 times f minus 32 over 9. Then I could put c over 1, and yet again, I can cross multiply. Delightful. I have 9 times c is 9c, 9 times c. 1 times 5 times f minus 32 would just be this. And now, instead of distributing, because inside the parentheses, I already have f, like the coefficient is currently 1, which is very nice, that 5 is being multiplied to this other factor containing the f, so I'm going to divide both sides by 5. Now I have 9/5c, or 9c over 5, either way is fine. Here the 5's cancel, and I'm left with f minus 32, right? Because 5 is a factor of the numerator, and 5 is a factor of the denominator, so I can cancel out the common factor. Now to get f by itself, I will add 32 to both sides. Plus 32, and I get my Fahrenheit, woohoo, is 9c over 5 plus 32. So if I'm told that it's 20 degrees Celsius outside, I could say, okay, well, 20 divided by 5 is 4. 4 times 9 is 36, and 36 plus 32 is 68. So then I know it's going to be a nice day. It's going to be 68 degrees Fahrenheit. So this is a really good one to know if you're traveling to another country that predominantly uses Celsius. These have been examples of formulas you may have seen in math or other classes and solving them for some other variable within them. Thank you for stopping by.